Project 2 Mask Roller Press Modeling. Task 3 Modeling of the Tooth Roller. Lecturer, Chen Xiaoyun. Hello, everyone. In this lesson, we will continue the study of the mask roller press tooth, modeling of the tooth roller. Last time, we finished the first part of the structure of the tooth roller. Then in this class, let's open UG software, continue to keep the learning spirit of precision, diligence, standardization, and innovation, and complete the modeling task of tooth roller in part 2. In this lesson, we will introduce the construction of this square tooth, as well as the method of winding plain teeth to cylinder. First of all, sketch out the square tooth. Click on Sketch to select the default plane. OK. Straighten the sketch surface. Show the copied sketch. The outline of square tooth. We can draw one of rectangles first, and then through the array to complete. The method of drawing by 2 points. The outline of this tooth. The left end is half of 91. From the center of the sketch. That is, 91 divided by 2. Then look at the height and position of height. We give the height dimensions. Let's get it away from this line. The distance is 6. Width. The overall width is 1. A rectangle of 1 times 1. Click on OK. Finish sketch. And then we click More here. Select Geometric Array feature. Choose the curve just drawn. Select Linear Mode. Specify vector. The vector direction is reversed along the y-axis. Select the appropriate space column. Drawing display the span of 91. The way to select pitch and span. Intercept 5 plus width 1 is 6. The span is 91. This is one of the directions. Then tick the second direction. The vector direction is chosen to go down. The array used here is the same pitch and span method. On the drawing, overall span is 9. 9 minus 3 rectangles is equal to 6. 6 divided by 2 widths is 3. Then its pitch is 3 plus 1. That is before. The span is 9. Preview results. We don't need the middle tooth shape. At this time, set up array here. Check frame only. Only the outer ring part is needed. Click on OK. Complete the setup of the array. F8. Straighten. Next. We put the rectangular box on the right half of the teeth by stretching. Select from the center of the axis to the right box. Extrusion height of 1. Get this part of tooth profile. Plain teeth with 3 tooth types is drawn out. Next, put the redundant sketches hidden. Show the first sketch. All curves are hidden, including the sketch. Then, how do you turn a plain tooth into a cylindrical tooth? At this time, we need to find in curved surface toolbar. To build with an overall deformation command, integral deformation in the command box by the method of surfaces. Let the basic plane, that is the tooth on the plane, become teeth on a curled cylindrical surface. At this point we need 2 planes. One is the basic plane of the stretching. and 1 is the control surface of the rotation. So before doing the whole deformation, let's make this stretch plane first. We only need to do half of this deformation region when it was originally stretched. It's all pulled out here. Just box it, press F8 to straight. Choose to hide the other half of the teeth. This part of the tooth. Move to the layer in the format here. 20 layers. Next, let's do a basic plane first. Click on Extrude. Select the curve drawn in the previous sketch. Specify vector direction. This direction is y-axis to the right. That is negative direction of y, to the right. Stretched distance is half the circumference of this cylinder. That is 75 diameter divided by 2, and multiply by pi. To get stretched length, click on OK. This is integrally deformed basic plane. When we pull out this piece, through careful observation, we will find the tooth was stretched in the opposite direction. Therefore, it is necessary to adjust its stretching direction at this time. Select the 3 kinds of characteristic teeth of that just stretched. Vector direction. Here we need to click reverse. Click on OK. Similarly, extrude the other teeth. The same reverse. The direction can't be wrong. And the text teeth are stretched in the opposite direction. Stretching of array geometric feature teeth. Reverse. OK. After the basic plane is made, then through the rotating, to select curve. Specify vector, x-axis direction. Around. X-axis towards specify point. Located 1 radius below the top edge ridge. That is 75 divided by 2. OK. Rotate 180 degree to obtain the control surface. Click on the surface toolbar again. Select the overall deformation command. Change the type to the way of surface. Select the tooth type made above. Be careful not to choose this one. Fundamentals. Select the basic surface. Select control surface. Turn off preview before selecting. Select control surface. If you need to make the whole deformation successfully, the UV direction of fundamentals and control surfaces must be isotropic. At this point, we need to adjust the UV orientation on both surfaces. In the basic surface, let's click U. Not this. Click on V. It's not here either. Cancel U again. Then UV comes to the lower left corner at this time. But the UV is just the opposite. Let's click the control surface here. Let both UV in the same direction, and then here in the deformation direction. Change to vertical control, object. In settings, check retain the input slice. Preview it first. No problem. Then let's click OK. Put the top. Hide planar tooth. Excess teeth. We hide it. Next, create the view. We need to put this half of the teeth. Mirror it to the other side. Here on the home page, click Mirror Geometry. Select Integral Deformation command. Specifies that the mirror plane is the middle XZ plane. Get the other half tooth. Click on OK. And then hide the surface. In Component Navigator, put cylinder drawn in front. Right-click. Show it. Hide all. Then sum it. Select cylinder. Box the other teeth. Combine it into a hole. Click on OK. Tooth roller model. These teeth on a cylindrical surface are now complete. If mirror the extra teeth, these teeth can be removed with the Replacement Surface command. Click on Replace Face. Select the top surface. Press Shift to cancel was selected by mistake. Replace it with the cylindrical surface in bottom circle. Click on OK. This is the creation of tooth roller model. Similar with other constructed teeth. I won't repeat it here. The creation of the axis is covered in the knife mold case, which is omitted here because of time. That's the end of the lesson about tooth roller. Thank you. In this class, we have finished part 2 of modeling tasks of tooth roller. Have you learned? Please answer the following questions. This is the end of this lesson. Thank you.